In this video, we are going to do some practice problems on substances, mixtures, elements, and compounds. So I like to say it is elements, compounds, and mixtures, but sometimes things are a little bit harder than others. So I have a little flow chart up here at the top. Basically, matter gets broken into two categories: substances and mixtures. In a substance, they are always homogeneous because they're only one thing. So a substance could be a pure element like pure helium or pure oxygen. A substance could also be a pure compound. So in other words, if I have a compound, just to review, is two or more different elements combined. So if I have just pure H2O in a glass, then that would be pure water. That is also a substance. If I have pure sugar, that would be a solid, but also still a substance. Okay, the phase doesn't really matter. So if you have just one element or just one compound, we're dealing with a substance. Mixtures have variable ratios. They can be hetero or homogeneous depending, and they are combinations of two or more different things. That's what makes it a mixture. So now you have to be able to name those two things. So an example of a homogeneous mixture would be sugar water. And if you notice, I just said the two things. It's sugar and water. That makes it a mixture. The fact that the reason it's homogeneous is because if I were to look at it and the water and the sugar was fully dissolved, I wouldn't be able to see the difference between the sugar and the water. That makes it homogeneous. Heterogeneous would be oil and water, because if I look at it, I can see the layering of the oil and the water. Whichever one is on top and bottom is totally irrelevant. You don't even need to know. You just need to know, well, they're not the same because they're not evenly mixed, so therefore it is heterogeneous. Okay, so let's go over some examples. And this is a key reason why you need to know your elements on your periodic table, because they're going to make this topic much easier. So let's talk about the first four. So iron. Iron, if you know your periodic table, you know that it is a element. And if I think about it, well, since iron's an element and there's nothing else other than iron there, then that also means it's going to be a substance. If it was iron and something, then it would be a mixture. So water. Water is a compound. Okay, it's H's and O's combined, hence the name. Water is just a compound. There's no second thing there. So it's not salt water or sugar water or sand in water. It's just water. So that's going to make it a substance as well, because it's just one thing. Dirt. Now dirt, if we look at dirt up close, it's made of multiple things. Therefore, it's going to be a mixture, because it's sand and clay and sticks and leaves and things like that. And so there's lots of different things that go into dirt. So it's definitely a mixture. And since if I look closely, I can see those different things, it's heterogeneous. In other words, they're visible to my eyes. I can see the different things. Sugar water. Well, sugar water is a mixture because it's sugar and water, hence the term. Be aware, they can show it to you this way, word-wise, or they can just give you the formula and expect you to know that that means sugar water. That's why you kind of have to need to know how to do those things or what those mean. So it's a mixture. And if I looked at it, I couldn't see the different parts, so it's going to be homogeneous. All right, so this is pretty much how you do it. Remember, there's in the first column, it can either be substances or mixtures. And if it's a substance, your only options are going to be either elements or compounds. And if it's a mixture, your next two options for the second column are going to be hetero or homogeneous. Okay, and so depending on what your answer to the first one is, you then limit your responses to the second. All right, and that should explain a lot of it. Just be aware, some of these I really kind of try to make these as easy as possible to visualize, so I'm only using certain examples. Let's talk about 13 and 14. 13 is flat soda. I gave Sprite as an example, and carbonated soda, we'll use Sprite as the same example. So Sprite, if you pour it out into a glass, it is a clear liquid. And the difference between flat soda and carbonated soda, well, you tell me. What would you see if the soda was totally flat? It would just look like plain old water, and that should actually answer all your questions. And if you look at carbonated soda, you're going to see a liquid, right? It's going to look like water, but there's going to be bubbles inside of it. So you're going to see two different things. And then that should answer your some of your questions. But be aware, whether the soda is flat or carbonated, they're both mixtures. And the reason is simple. Think about what soda is: sugar, sometimes food coloring, flavoring, water. So it's a mixture of a bunch of different things no matter what. Whether you have the bubbles or not, it's still a mixture. It's just now a matter of one of them would be a heterogeneous mixture and the other would be a homogeneous mixture. So that concludes the practice for the ones that I wanted to go over. The rest will obviously be either done in class or for homework.